All right, question 20 on the math subject GRE practice test. I think with this video, I'm gonna do something a little bit different. I'm gonna answer the question a little bit more directly and quickly, and then kind of go back and fill in the gaps and talk about the specifics for people who need it. So what we're doing in this problem is we're trying to figure out the second derivative. Second derivative of what? Second derivative of the composition of two functions, f of g. First comment here is I hate this notation, but that's the notation they're using, so I'll use it. Maybe at the end I'll go back and do this again with slightly different notation. But for now, if I'm looking for the second derivative, what I would do is first find the first derivative. To figure out the derivative of a composition, you use the chain rule. The derivative of f of g is f prime of g times g prime. Cool, I got the first derivative. Unfortunately, that's not what the question's asking for. The question wants the second derivative. No problem. To figure out the second derivative, all I have to do is take the derivative of this first derivative. So here's my first derivative, and I want the derivative of that. Figure that out, I'm going to have to use the product rule. Why the product rule? Because I got something times something else. What the product rule tells me is anytime you're taking the derivative of the product of two things, what you do is you take the derivative of the first thing, leaving the second thing alone, and then add to that the derivative of the second thing, leaving the first thing alone. So first, let's figure out the derivative of f prime of g. Well, again, this is a composition, so I'm going to have to use the chain rule. When I'm using the chain rule on this thing, I take the derivative of the outer function, the first function, the f prime. So the derivative of that f prime is f double prime. I leave the inner function, the g, completely alone. Then I'm not done. I got to multiply that by the derivative of the inner function, g prime. What I've written in blue here is the derivative of this. The product rule tells me to multiply that by this thing, the second factor in my multiplication, left completely alone. To that I want to add the derivative of that second thing. The derivative of g prime is g double prime times the first thing left completely alone, f prime of g. This right here is my answer, although I suspect in the answer key they wouldn't write times g prime. They changed that into g prime squared. One other little change I can make, since multiplication is commutative, instead of writing g double prime times this thing, I could write this thing, f prime of g, times g double prime. What we now have is exactly what's written here. So it looks like D is the answer to our question. If that makes sense to you, great, you're good, you're done with 20. In case you struggle with that, a couple key things that you need to solve this problem. They're the chain rule and the product rule respectively. What the chain rule says in this notation is exactly what I wrote in this line. The derivative of a composition of two functions is f prime of g times g prime. In slightly different notation, instead of writing f of g this way, I could write it this way. And written this way, I kind of like to include my variable, maybe the letter x. If you're more comfortable with function composition being written this way, we can restate the chain rule by saying the derivative of this is equal to f prime of, take the derivative of the outside function, g of x, leave the inside function completely alone, but then you're not done, multiply that by the derivative of the inside function, g prime of x. Saying the same thing, slightly different notation. The other rule we ended up using is what's called the product rule. If I don't call out my variable explicitly, what the product rule says is that f times g prime, the derivative of a product of two things, is f prime g plus g prime f. If you're more comfortable expressing functions by explicitly stating their variables, so I don't know, f of x times g of x maybe, and you want to take the derivative of that product, you'd get f prime of x times g of x plus g prime of x times f of x. With that in mind, we can redo this problem, but one more note on notation. Maybe you've seen the symbol d over dx used to represent the derivative. To try to make things clear, I'm going to use this symbol to kind of signify work that still needs to be done. I still need to take the derivative of something. So like in this top version of the product rule, I might use this symbol on the left-hand side, say that the derivative of f times g is equal to, and then on the right side I'll switch notations. Instead of using d over dx of f to represent this derivative, I'll write f prime g plus g prime f. I know it might look strange to be kind of mixing notations like this, but the advantage to writing it this way is it makes it a little bit easier to show your work on problems like this that get a little bit complicated. So let me try to redo this problem, maybe with this more user-friendly notation, using this to kind of show my work. Let's first figure out the derivative of f of g of x. Note this symbol, meaning I want to take the derivative of this stuff. Well, what I do is I take the derivative of the outside function, which is f prime, and then leave the inside function completely alone. So I'll write of g of x, but then I'm not done. I have to multiply that by the derivative of the inside function, which I could say derivative of g of x, and then on the next line change this into g prime of x, but that's probably a little bit of overkill. Hopefully you follow me writing it this way. I think where this notation will come in handy is figuring out the second derivative. So to figure out the second derivative of f of g of x, in other words, the answer to the question, what I need to do is take the derivative of this first derivative, f prime of g of x times g prime of x. When I stare at this thing, I first see the product rule. I got something times something. So to just kind of set up the product rule, I'll have to take the derivative of the first thing, f prime of g of x, and then I'll multiply that by the second thing, g prime of x, and then I'll add to that the derivative of the second thing, the derivative of g prime of x, and multiply that by the first thing, f prime of g of x. Note that this and this is completely done. It doesn't have this d over dx symbol in front of it. It's just this factor and this factor where there's still work to be done. So to write my final answer, I can leave this completely alone, this g prime of x, and I can leave this completely alone, f prime of g of x. The work that I still have left to do is take this derivative and take this derivative. There's a little bit of a template of where everything's going to go. Let's first take care of this blue one here. I think that one's a little bit easier. The derivative of g prime of x is just g double prime of x. That's easy enough. It's this one where things get a little bit difficult. The derivative of f prime of g of x is going to involve the chain rule. So remember from up here that when you're taking the derivative of a composition of two functions, you first take the derivative of the outside function, leaving the inside function completely alone. But then you're not done. You multiply that by the derivative of the inside function. That's all we're going to do down here. It's just now playing the role of the outside function is f prime. So when I take the derivative of that f prime, I get f double prime. I then leave the inside function completely alone, so it's still g of x, and then I remember that I'm not done. I have to multiply that by the derivative of the inside function. The derivative of g of x is g prime of x. The answer that we got down here is identical to the answer that we got up here, just written in slightly different notation. My hope is just if you struggle with the calculus up here, this kind of made it a little bit more clear for you.